Next one is ApplySpec. This is pretty interesting. So given that you have an object where you have keys that contain functions that, when given a series of arguments of type A, B, and so forth up to M, will produce you a value of type V, right? Given that you have that object, an object with functions under keys, if you first give that, you will get a function that, when given all of these arguments of type A, B, all the way up to M, notice here that the order is the same, right? So they're saying if you have a function that accepts an A first and then a B, then when you pass this thing, you need to pass in the same order. So given that we then apply these arguments in that order, or you will get a function that accepts arguments in that order and will produce something that has keys with values. And notice that this value then here is of type V, which is what these functions produced. So this looks a bit hairy, but it's actually pretty cool and pretty useful. So the definition says that given a spec object recursively mapping properties to function creates a function producing an object of the same structure by mapping each property to the result of calling its associated function with the supplied arguments. This looks totally messy, or this sounds totally messy, but let's copy this example and let's look at that. So we'll paste that in, and then we'll just console log this function call. So let's just run that first, right? We can see that runs properly. Let me just indent that, right? So what we get back is that we get an object where the key sum points to 6, the key nested points to a new object, where inside the key mul points to 8. And if we look at our original data, we didn't start with an object, we simply started with 2 arguments. So we're defining this function getMetrics, and then we're calling it with 2 and 4, right? So these are the A, B, so our A is 2 and our B is 4, right? Like metaphorically. And what we're doing is that we're saying, okay, getMetrics is a function that's created from ApplySpec. So remember, we pass a spec and we get back a function. So we pass a spec that somehow interacts with A's and B's and we get back a function that will accept this series of A, B, and so forth. And what happens is that all these values that we pass to getMetrics will simply be passed through each of the functions that we have as values under these keys. And actually, let me indent this like so, also to emphasize. And then maybe it's better if we just do it like this. So, but just to emphasize that this is nested, right? So it recursively traverses this object and finds all of the functions, right? So add here and applies this function to the arguments that we've passed. In other words, 2 and 4, right? And here it passes 2 and 4. So because we have add here, we add 2 and 4, which gives us 6, which is here. And because we have 2 and 4 here, when we use multiply, we end up with 8, which we have here. So pretty cool, right? So let's add diff here, just so we have something as well. So subtract. Oh, sorry. I mean, now I added the arguments here, but we should of course have diff here and then r.subtract. And this 2 should just work fine, right? And then we get the diff is -2. And maybe we would want to flip the arguments here for some reason, right? And that would work as well. We diff 2. So this is pretty darn useful and pretty darn powerful. And sometimes it's just the easiest way to get the stuff out that you need. But that's ApplySpec. I think we'll jump forward because probably that makes a lot of sense. So the next function is ApplyTo. And ApplyTo, let's just begin by reading the definition. It takes a value and applies a function to it. And this function is also known as the thrush combinator. So again, remember we've talked about combinators like the S combinator and the K combinator, and this is then known as the thrush combinator. So let's look at the definition here. So it says given an A and given a function from A to B, it will produce a B. So this is pretty straightforward, right? So if we look at their example here, it says that, okay, they're creating a function which they call T42, and they say apply to 42. So actually, if you think about this, what happens is that we're doing this in the opposite order of what we usually do in functional programming. So in functional programming, usually we keep all of the sort of configurational arguments first, or all of the functions we pass first, and in the end we pass the data, because this is very useful for composition, because you can compose functions and then apply the data in the end. But here, this function, or the thrush combinator, we can use when we have the opposite scenario. We can use it when we have a scenario where we have the value, but we don't know the function that we want to apply yet. So let's just let's also just build something here as well. So we say, let's say R.applyTo. Actually, let's do their example 42. So this will give us a function. But then we need to, but that's because it's a function expecting a function, but it's a function that's wrapping a value that's expecting a function. And they're passing our identity. So let's do the same thing, right? And this will give us 42, right? So, and that's because, I mean, identity, as we talked about before, identity is essentially defined as this, something like that, right? Like whatever you pass to it, it just responds with that. But what we could do is, of course, we could pass something else, like let's say molt2. So, sorry, it's not called molt, it's called multiply. Sorry, it's just, I usually define them as add and molt and sub, and this is why. But so we pass molt2, we get 84 because we had 42, because 42 times 2 is 84. And yeah, I mean, this is potentially useful if you have the value first. So pretty neat, right? And this is why we have a here, because a then is the value, and then we have a function from that we can apply to something of that type, of type A, and produce something of type B. And when we have both of these two things, we get something of type B. Next one, ascend.